Hello everyone, welcome back to my channel. Today we are going to learn structure of atom. An atom is made up of three particles, namely electron, proton and neutron. Okay, and electrons are the negatively charged particles and it will have zero mass, whereas protons are the positively charged particles and it will have unit mass. That is, mass of the proton will be equals to 1 unit, and one positive proton and one negatively charged subatomic particle will neutralize each other. It will get balanced. Okay, and we are having one more neutron. Neutron will have no charge. Okay, and also the mass of the neutron will be equals to mass of the proton, that is 1 unit. Next is spectrum. Spectrum, the group of wavelength or frequencies, we call it as a spectrum. Okay, a rainbow, as you already know, that it will contains of 7 colors: vibgyor, violet, indigo, blue, green, yellow, orange and red, which are called spectrum. Okay, in a rainbow, these seven colors are spread continuously with varying intensity. Due to the varying intensity, you are able to see a various different color at different point. Okay, it varies from one point to another. Wave nature of light. When a still pond, there is a pond, if you disturb it by throwing a stone or something, the water ripples at scene. Okay, they are formed to transmit the disturbance in the form of waves. So when a drum is beaten, it vibrates. Yes or no? You are able to hear the sound because of the vibration, right? So if anything is vibrating, sound waves are generated, right? So similarly, when the electric charge moves back and forth and or vibrate, the electromagnetic waves are produced. The velocity of an visible light is an electromagnetic waves, and its wavelength is 3 into 10 to the power of 8 meter per second. Electromagnetic waves have different frequencies. So the complete ratio frequency of electromagnetic waves together is called as an electromagnetic spectrum. Okay, as we have already discussed about rainbow. Okay, because of the different wavelengths, you are able to see different colors. So the electromagnetic wave spectrum is a continuous range of wavelength, starting from the smallest wavelength gamma rays to longest wavelength radio waves. The wavelength of visible lights are longer than UV rays and smaller than IR rays. Thus, in electromagnetic spectrum, visible light is in between UV rays and IR rays. Okay. Max Planck changed the continuous energy concept in electromagnetic energy. He introduced a new assumption that energy emitted is always a multiple of h nu. Okay, h nu means if E is the energy of a specific frequency of radiation emitted or observed, then E is equals to h nu, where h is nothing but the Planck's constant and the value of h is 6.625 into 10 to the power of minus 34 joules per second. Okay, so here electromagnetic energy can be gained or lost in discrete values and not in continuous manner. So thus the absorption or emission of a light spectrum is a collection of a group of wavelengths according to Max Planck proposal. Let us do an activity to see metal produce different colors in frame. The chemical required for this is cupric chloride, strontium chloride, concentrated hydrochloric acid, okay, watch glass and non-luminous frame. So here what we are doing, we are taking a pinch of cupric chloride in a watch glass and we are making a paste with concentrated sulfuric acid. Okay, now we are taking this paste on a platinum loop and introducing it to a non-luminous flame. So then a green color flame is produced. So by this activity, it can be seen that each element or metal emits its own characteristic colors in flame. Bohr's model of hydrogen atom. So the scientist Neil Henrik David Bohr stated that electrons in an atom occupy stationary orbits of fixed energy at different distances from the nucleus. So whenever an electron is in excited state, that is, it is jumping from lower energy level to higher energy level, energy is observed. Similarly, when an electron is moved to any of the lower energy levels from higher energy levels, the excess energy is emitted out. So in an atom, the electrons have only certain specific energy values, right? Say E nu, E2 nu, etc. So the energy of the electrons is quantified. The orbits corresponding to these energy, we call it as a stationary states, and the possible values of this energy are called energy levels. Okay, so the lower energy state of electron is known as the ground state. When an electron gains an energy, that is it is observing energy, it moves to higher energy level. Okay, then electron loses the energy and come back to its ground state. So the energy emitted by the electron is seen in the form of electromagnetic energy. Okay, after moving to the excited state, the electron returns to its ground state by releasing excess energy, that we call it as a electromagnetic energy. Bose-Sommerfeld model is nothing but a modification of Bohr's model. So in Bohr's model, they are talking about energies. In this, what Sommerfeld has done is he put one more, like one elliptical orbit as a nucleus, and the other is nothing but the surrounding ones. Okay, so here what he has done is he has taken first Bohr's circular orbit, and then he added one more elliptical orbit to Bohr's second orbit, and so on. Okay, so because this will result in periodic motion of the orbits. Okay, and if the central force coincide with one of the foci of the orbit, okay, based on this concept, Sommerfeld modified the model and added elliptical orbits. Quantum mechanical model of an atom. So according to this model of an atom, instead of orbits of Bohr's model, the electrons are thought to exist in a particular regions of space around the nucleus at a given instant of time. Okay, so here the region of space around the nucleus where the probability of finding the electrons is maximum, we call it as a orbital. In a given space around the nucleus, only certain orbitals can exist. Each orbital of a stable energy state for the electron is described by a particular set of quantum numbers. So we are having different types of quantum numbers. We are having 4 types of quantum number: principal quantum number, angular momentum quantum number, okay, and magnetic quantum number, and spin quantum number. Okay, so the first one is principal quantum number. The principal quantum number indicates the size and energy of main shell and is denoted by n, where n is equals to 1, 2, 3, 4, as you can see in the picture. With increase in n value, the size of the main shell also increases. Next is azimuthal quantum number or angular momentum quantum number. The angular momentum quantum number indicates the shape of each subshell and is represented by using L, where L is equals to 0, 1, 2, 3. L is equals to 0 means S, L is equals to 1 means P, L is equals to 2 means D, and L is equals to 3 means F. Okay. Next is magnetic quantum number. Magnetic quantum number describes the orientation of orbital with respect to its orbital in region of space of an atom. So it is denoted by ML. Okay, for it has values between minus L plus 1, so on, L plus 1, L minus 1, at the last L. So here we are having subshells. Again, you will see L is 0, 1, 2, 3. Subshell will be SPDF, and number of degenerated orbitals will be 1, 3, 5, and 7. Spin quantum number explain the properties of electron. The two possible orientation of electron spin, that is clockwise and anti-clockwise, as you can see in the picture. So it is plus 1 by 2 and minus 1 by 2. Pauli's exclusion principle states that no two electrons in an atom has same set of quantum numbers. That is, if the 3 quantum numbers n, l, m are same for any 2 electrons, then the electrons will have different ms. The electrons with opposite spins will pair. So in helium atom, the first electron occupies first orbital, that is 1s. Now the second electron with same n, l, m values but with different ms, opposite spin, will join first electrons and pair. Okay, like this in helium atoms, the paired spins are represented as up arrow and down arrow, whereas ms of one electron is plus 1 by 2 and the other electron is minus 1 by 2. This is Aufbau principle. So Aufbau is a German word and it means building up. So in ground state of an atom, the electrons are filled in the atomic orbitals in increasing order of orbital energy level, and this is explained by Aufbau principle. So that is, the electron first occupies the atomic orbital with least energy level. The last in this chapter is Hund's rule. So as per Hund's rule, the pairing of electron depends only after filling available degenerate orbitals with 1 electron each. So according to Aufbau principle, the order of atomic orbital is 1s, 2s, 2p. Okay, therefore the atomic number of carbon is 6. So thus the number of electrons will be 6. So the first 4 electrons fill is 1s and 2s orbitals respectively, and the last 2 fill 2p orbitals. Similarly for other elements. Thank you for watching. Please like, share and subscribe to my channel for more videos. Thank you.